Today we're going to be looking at color by matrix. So we're going to use some of the matrix addition and matrix scalar multiplication we learned yesterday. We're going to practice that and we're going to do a coloring activity. So today's objective is I can correctly perform matrix addition and scalar multiplication of a matrix in 3 out of 4 problems. So similar to what we have done before. So let's look at a couple of examples. Looks like we have matrix addition in this first one, right here. So if you'll remember how we add matrices, we're going to take corresponding elements and add them together. So 16 plus negative 12 is going to be the number that's in this first position in the upper left-hand corner. 16 plus negative 12 is going to be positive 4. And then for the upper right hand, we'll get 8 plus negative 3, which is 5. Lower left-hand corner, we'll do 3 plus 0, which is 3. Lower right-hand corner, we'll do 3 plus 5, which is 8. We put square brackets around the whole thing, and that is our solution. That's how we add matrices. On the second example, be really careful to note that we're actually subtracting this time. It works the same way, but we need to remember to subtract all these second numbers instead of adding them. So our first element here, 1 minus 3 is negative 2. 6 minus negative 5, so minus a negative will be add. So 6 plus 5 is going to be 11. 4 minus 5 is negative 1. Negative 2 minus 7 is negative 9. We're basically just doing all the adding and subtracting. 3 minus negative 1. So subtract a negative is to add. 3 plus 1 is 4. 4 minus 0 is 4. We put square brackets around it, and that is our solution matrix. What about these two matrices? Do you think we could add these together? So remember, to add matrices, we need to add corresponding elements, corresponding indices. So let's see, our upper left-hand corner would be this one, 16 and then 4. We could add 16 to 4 and we'd get 20. What would we add this negative 2 to? There's nothing there. So actually, we cannot add these two matrices together. And the reason is that they are different sizes, or what we'd call different dimensions. This first one has 2 rows, we can count on 1, 2, and 2 columns, 1, 2. So we'd write this as a 2 by 2 matrix. This one, on the other hand, has 1, 2, 3 rows, and only 1 column. So this would be a 3 by 1 matrix, 3 rows by 1 column. You can see that these dimensions are different. They are not equal. So adding is not something we can do. All right, so let's look at scalar multiplication now. Scalar multiplication, remember this word scalar just means a number. And to multiply, we're basically just distributing this 2 to each element of the matrix. So 2 times 12 is 24. 2 times negative 3 is negative 6. 2 times negative 5 is negative 10. Notice our matrix stays in the same orientation. We don't write this as a single row now. We should get a matrix that's the same size as our original matrix when we do scalar multiplication. Let's try this bottom one, -5, and we're going to multiply that by each of these elements. -5 times 1 is -5. -5 times 6 is -30. -5 times -5, okay, so a negative times a negative is a positive. 5 times 5 is 25. And then -5 times -1. Again, a negative times a negative is a positive, and 5 times 1 is 5. So there's our scalar multiplication matrix. And finally, we can actually add and multiply in the same problem. Notice we have a multiply here and an add. But here's the question, which would we do first? Do we perform this addition first, or do we perform this multiplication first? Well, we have good old PEMDAS, and PEMDAS still applies to matrices. So we're going to do our multiplication first, then our addition. Okay, so we'll perform this multiplication 2 times each of these elements. 2 times 6 is 12, 2 times -3 is -6, 2 times -4 is -8. And now we need to add the second matrix, which is 5, 1, 8. We add those together, we get 12 plus 5 is 17. -6 plus 1 is -5. -8 plus +8, that is 0. And that is our final matrix in this problem. That's our answer. So we have one new concept today, and that's called indexing, matrix indexing, which is a way to refer to a particular element of a matrix. So it's how we say, I want to talk about the upper left-hand corner, or I want to talk about the one that's in the third row, second from the right, something like that. We have a very specific syntax for talking about particular elements of a matrix. And this is it. We refer to a particular element of a matrix with this syntax, A to 1. So that's a subscript like this, A to 1. And this first number indicates the row. This is the row. The second number indicates the column. So in this matrix down here, we're asking what's the value of A to 1? We can number the rows 1, 2. We can number the columns 1, 2. And we're looking at, here's our row. That's our first element. Row 2. Our second element tells us the column. This is column 1. So if we circle row 2 and we circle we circle column 1, you can see where they intersect is right here. So the value of this index, the value of A21 in this case, is 9. So here's some more examples of matrix indexing, just some different sizes. You can see they follow the same pattern. The row number stays consistent in each row. Here's row 2. Here's row 3 in this one, row 4. That's the first subscript each time is the row number. And then the second number stays consistent in each column. This is column 1. This is column 2. Down here's column 2. This is column 3. You can see all of these have the same column number 2, column number 1. So this is how we refer to particular elements of any size matrix. So our activity today involves solving addition and scalar multiplication matrix problems. And then we're going to do a color by number based on our solutions. So the color by number is informative, and the link is in your class. Notice there's also a printable version available. If you'd like to do this on paper instead of informative, that's totally okay too. You can print it out, use colored pencils or crayons or anything that you want, and send me a picture of it. That'll work. And I will go over the first couple, maybe not the first couple, but a few problems from the formative just to show you how exactly it works. So here I am in formative. This is the assignment, and you can see this first one here, show your work. This is going to be where we do the coloring. This is where we're going to do the color by number. So let's go look at the first sheet of problems. Now, this is graded entirely on the picture, so you actually don't need to show your work on these matrices if you don't want to. You could do it on paper. You don't have to turn it in, though. You do have space here in the formative to show your work if you want to use it. So that's basically scratch paper for you, but you are not required to use it. You will be graded entirely on the picture and not on artistic quality. I'm mostly just looking for the right colors in the right place. So let's go look at this first one. And so we're doing matrix addition here. We're going to add each element, each corresponding element the way we did before. So 1 plus 2 is 3. 0 plus 5 is 5. 2 plus 1 is 3. Negative 3 plus negative 1 is negative 4. 1 plus 4 is 5. And then 1 plus 5 is 6. And that is our matrix. But we don't end there. Once we have our matrix, we need to look at a particular entry. We need to look at A12. Remember, this refers to, we write this, A12. This is the row, row 1, and then column 2. So we're going to look at row 1, which is right here, and column 2. That value is 5. So everywhere in the picture where we have a 5, we're going to color that pink. Let's go back and actually do that. Let's go back up to the color by number. Let's see, it looks like there's a pink there, or a 5 there. We'll color pink. There's a 5 there. There's a 5 over here, one down here, and maybe this one as well. Those are the only ones I see. And if you're doing this informative, I like to come up here. You can choose a different color. Here's our pink color. And I like to use this largest brush. That makes it really easy to color these in really quickly for me. I don't get them super exact inside the lines. If that's important to you, you can use a smaller brush. But really, I'm not too concerned about it right now. So I'll just color in these spaces that have 5s in them. There's a 5. Let's see, there's this triangle down here. And we said there's one more of these over here. So that's how you'll do the color by number. You'll come back from the problems and color in the applicable spaces with the applicable color. Now let's look at a couple more problems because some of these are a little bit more complicated. They have variables in them and we don't want it to throw you. So let's look at problem number 5 as an example. Get my smaller pencil out here. Let's look at number 5. So this, you can see there's a variable out front, but there's no add sign. This is multiplication again. Very similar to when we're multiplying numbers, sometimes we will exclude the little dot or the star symbol, and that means it's still multiplication. So this is going to be x times all of these inside elements. We're going to distribute the x to each element. So x times 4, that'll just be 4x. X times 2x. Now we have to kind of think back in our brains. What is that? How do we simplify that? Well, x times x. How did we... There's a simpler way to represent that. We talked about that way back in Unit 1. And this is an exponential. This is x squared. So x times 2 times x is going to be 2x squared. That's our second element of this matrix. X times y is xy. And x times negative 10, that can't be simplified anymore either, so that's just negative 10x. There's our matrix. The entry we're looking for is A14, so row 1, column 4. Here's row 1, it's the only row, and here's columns 1, 2, 3, 4, this row, this column right here. So this is the element that we need to color yellow. Negative 10x, we're going to color yellow. Let's go back and do that. So let's see, I see a negative 10x here, negative 10x here, negative 10x, negative 10x. Oh, there's one up here. Okay, so we're going to color all of those yellow. Once again, I'm just going to use this big brush. We get 10x there, 10x here. Oh, and they're actually in the middle as well, negative 10x. There we go. I got a little excited, but we get the idea. So negative 10x, we're all colored yellow. Oh, I missed one. There's one over here too. All colored yellow. So let's look at one more problem before I set you free on this to do it on your own. Let's look at problem number 9, the first problem on page 3. This one involves some combining like terms, so don't let it throw you. We've done this before, we just maybe haven't done it in a little while. So this is addition. We've got our add sign there. We're going to add corresponding elements. So we'll do the top ones first. This will be negative 6 plus y. That's our first element. We're going to add that to 6. Our second element is negative x plus 2x. Our third element is 6z plus 2z. And now we can simplify this a bit by combining like elements. Let's see, negative 6 plus y plus positive 6, those will cancel, the 6's will cancel, and we're left with y. Negative x plus 2x, well, we can combine like terms. 2 plus negative 1 is just 1, so that equals x. And then 6z plus 2z, again, we combine like terms and we get 8z. Well, pretend that that last one was outside the z. There we go, that's better. The entry we're looking for here is A11, so row 1, column 1, this value is y. We're going to color y green, so let's go back and do that. Now if you want to do all the math all at once and then do all the coloring all at once, that's totally fine too. You do you. So I'm going to go choose green and my big highlighter. Also notice I'm using this scribble tool. I failed to point that out earlier. And I'm going to find all my y's. So there's one right there. I'm going to color that green. And here's one here. Color that green. And do I see any other y's? I don't think I do. So that's everything for that problem. So there are your examples for this formative. And we'll just go back and look at our objective really quick. Our objective today was I can correctly perform matrix addition and scalar multiplication of a matrix in 3 out of 4 problems. So we'll just get a bunch of practice doing that today,